Okay, so hopefully for the final time, I will be explaining how to solve WeBWorK number 3, problem 18. The problem is dx dt minus 2x equals cosine of 2t with the initial value of x of 0 equals 3. So when you look at this, we see that this is a linear first-order differential equation in standard form. So we can see that p of t equals negative 2 and f of t equals cosine of 2t. So now we can find the integrating factor for this. So mu equals e to the integral of p of t dt. And because p of t equals negative 2, mu equals e to the integral of negative 2 dt, and mu equals e to the negative 2t. So now we're going to multiply this through that differential equation. So e to the negative 2t dx dt minus 2e to the negative 2t times x equals e to the negative 2t times cosine of 2t. Now we can see that this over here is the derivative of the product of e to the negative 2t times x. We can see this because the derivative of x is dx dt, and the derivative of e to the negative 2t is negative 2e to the negative 2t. So we can write this like d dt of e to the negative 2t times x equals e to the negative 2t cosine of 2t. And now we'll take the integral on both sides with respect to t. So on the left side, this is easy. So the integral cancels out the derivative, and we're left with e to the negative 2t times x. Now on the right side, this is a little harder to solve because there's no easy way to simplify this. So we're going to do this with integration by parts. So I'm going to switch to a new sheet of paper for that. Okay, so we're going to start with the integral of e to the negative 2t cosine of 2t dt. We'll say that u equals, cosine of 2t, and du equals negative 2 sine of 2t. dv equals e to the negative 2 dt, which makes v negative 1/2 e to the negative 2t. So we're going to write this out now. So the integral of e to the negative 2t cosine of 2t dt equals u times v, so negative 1/2 e to the negative 2t cosine of 2t minus the integral of v du. So negative 1/2 times negative 2 is 1, so e to the negative 2t sine of 2t dt. So we see that the integral we get here is still not easy to integrate. So to solve this, we'll have to do different integration by parts again. So u equals sine of 2t, du equals 2 cosine of 2t dt, dv equals e to the negative 2t dt, and v equals negative 1/2 e to the negative 2t. So we'll put this in again. E to the negative 2t cosine of 2t dt, the integral of that equals negative 1/2 e to the negative 2t cosine of 2t minus, and I'll put brackets in here, u times v, so negative 1/2 sine of 2t e to the negative 2t. I could have reversed the order there. Minus v du. Negative 1/2 times 2 would be negative 1, so negative e to the negative 2t cosine of 2t dt. And to do this, I'm just going to distribute to the negative. So we're left that this integral equals negative 1/2 e to the negative 2t cosine of 2t plus 1/2 sine of 2t e to the negative 2t minus the integral of e to the negative 2t cosine of 2t dt, and I want to put in the value, the constant here, of c. I'm going to leave it as c1. Okay, and again, we can't integrate this, but what we can do is we can add it to the other side because these are the same. So when we add it over, we get 2 times the integral of e to the negative 2t cosine of 2t dt equals, and I'm going to pull out the 1/2, 1/2 times negative e to the negative 2t cosine of 2t plus e to the negative 2t sine of 2t, close the parentheses, plus c1. And finally, to finish this all off, we're just going to divide every term by 2. So we get that the integral of e to the negative 2t cosine of 2t dt equals 1/4. I'm going to arrange this to make it look a little nicer. E to the negative 2t sine of 2t minus e to the negative 2t cosine of 2t plus c2, where c2 equals 1/2 c1. Okay, so we have our integral here, and now we're going to plug it back into the original thing we had. So, things are shifting, I'm sorry. Okay, e to the negative 2x times x equals 1/4. I guess we can pull out e to the negative 2t. E to the negative 2t times sine of 2t minus cosine of 2t, close that up, plus c2. And finally, to get this in terms of x, divide every term by e to the negative 2t. So x equals 1/4 sine of 2t minus cosine of 2t plus c2 e to the 2t. Because we're dividing by a negative, we can make that a positive there. Okay, so there we have our general solution. But this is actually an initial value problem because we have x of 0 equals 3. So if we put x of 0 equals 3, we know that t equals 0. So 3 equals 1/4 times sine of 2 times 0 minus cosine of 2 times 0 plus c2 e to the 2 times 0. So we're left with e equals 1/4 of 0 minus 1 plus c2. E equals negative 1/4 plus c2, and adding 1/4 to the side. So 3 would be 12/4 plus 1, 13/4 equals c2. So finally, if you want to plug this into the equation, at this particular value of x of 0 equals 3, we get the particular solution of x equals 1/4 sine of 2t, oops, forgot the brackets, minus cosine of 2t, plus, subbing in c, 13/4 e to the 2t. And that is our particular solution. Solution when x of 0 equals 3. Okay, and And that's how you solve that problem.